Dear friends, welcome to the next problem of gears, problem number 16. The data of the problem is like this. A rack is driven by a pinion having 24 involute teeth and a 140 pitch circle diameter. The addendum of both the pinion and the rack is 6 Determine the least pressure angle which can be used to avoid interference. For this pressure angle, find the minimum number of teeth in contact at a time. Friends, let us note down the given information. Number of teeth of pinion is given 24. Pitch circle diameter of pinion is given 140 Addendum of both rack and pinion is 6 We have to find out minimum pressure angle to avoid interference, and we have to calculate contact ratio. Friends, we know that for rack and pinion arrangement, to avoid interference, minimum number of teeth of pinion is given by this relation. T minimum is equal to 2 into addendum coefficient AR upon sin phi square. But here the number of teeth are given 24. So we have to find out minimum pressure angle for given number of teeth to avoid interference. So rewriting the above equation, we can find sin phi minimum is equal to under root of 2 into AR upon T. Let us say relation 1, and where AR is addendum coefficient. And we know that the addendum is given by addendum coefficient into module. That is, addendum is equal to AR into M. Addendum is given 6. That is, AR into module is nothing but pitch circle diameter divided by number of teeth. So substituting the values, we found it is equal to AR into 5.83. So addendum coefficient AR is equal to 6 divided by 5.83, that is equal to 1.029. Now from relation 1, we can write phi minimum is equal to sine inverse of under root 2 AR upon T. On substitution of these values of AR and T and calculation, we found phi minimum, that is equal to 17.02 degree. Now minimum number of teeth in contact at a time is nothing but contact ratio, and we know that contact ratio is given by arc of contact divided by pitch. Let us say relation 2, and arc of contact is nothing but path of contact divided by cos phi. Let us say relation 3, and for rack and pinion mechanism, the path of contact is given by this relation, that is under root of RA square minus R cos phi whole square. Let us say relation 4, where R is pitch circle radius of pinion given by pitch circle diameter by 2, and on calculation we found it is equal to 70 and RA is nothing but addendum circle radius of pinion, that is R plus addendum, and we found RA is equal to 76 millimeter. Using relation 4, substituting this value, we found on calculation path of contact is equal to 35.997 millimeter. Now using relation 3, we found that is arc of contact is equal to path of contact divided by cos phi, and on calculation it is found 37.64 millimeter. Using relation 2, contact ratio is given by arc of contact divided by pitch, and it is nothing but pi into module. And substituting the values, module is nothing but pitch circle diameter by number of teeth. So we found contact ratio is equal to 37.64 into number of teeth of pinion divided by pi into pitch circle diameter of pinion, and on calculation it is found that contact ratio is equal to 2.053. So we can conclude that the least pressure angle to avoid interference is 17.02 degree, and the minimum number of teeth in contact at a time is equal to 2.053. Thank you friends. Again I insist you to write in comment if you having any query or question or any other problem to be solved. You are most welcome. Thank you.